Hi friends, the today's topic, new topic is properties of nuclear forces. Right, it is very important for the exam point of view. So don't forget watching this video till the end. So here I am not making video more than half an hour. So below half an hour videos are there mostly. So for you only, for keeping your data in my mind only, I am preparing these videos less than the half an hour only. Okay friends, so for this please encourage me by subscribing. Okay, first nuclear force. What is nuclear force? Nuclear force, see, the short range attractive force between nucleons in the nucleus is called nuclear force. Right? Nuclear force is a attractive force and is a short range force. Right? And this force can act within the nucleus, among the nucleons within the nucleus. So that is why it is called nuclear force. Next, following are the properties. Nuclear force have following properties. So these are the important properties. First property, these forces are attractive forces between proton and neutron. Right? Overall effect of nuclear forces is attractive. So here the in between the proton attraction will present. Proton neutron attraction present, proton attraction present, and between the neutron and the neutron attraction force is present. Okay, so I just in the last video I explained you in between the proton and proton less Coulomb laws are valid. So less Coulombic force will be there. So but more nuclear forces will act. Right. Next, second one is these forces are strongest in the nature. In general, actually, how many forces we have? One is a gravitational force, right? So generally, in nature, first force is gravitational. Next is electrostatic force, and third one is magnetic force, and fourth one is a nuclear force, that is the strongest force. So why it is strongest? It means it can act with a in between the nucleons at very short distance. So that is why this force is the strongest force among all the force. And next, third point is they are spin dependent. So nuclear force depends on spin of proton and neutron. Right? So how the spinning? So because of spinning only nuclear forces will create. So attraction forces will create because of spinning of neutron and proton. So that is why they depends on what? Spin. Next, fourth point. These forces are short range forces. That is, they are effective within the nucleus diameter of order of 10 to the power minus 15 meters. Right? So these nuclear forces can act between the nucleons, between the protons are proton neutrons or neutron neutrons. When these nucleons present at a distance 10 to the power minus 15 meters. So within this distance only these forces can act. So that is why these forces are short range forces. If the neutron is here and proton is here, these are at a distance 1 micron or 1 millimeter distance, then cannot act. Okay, this force cannot act. Okay, so that is why these are the short range force. And the next fifth point is these forces are independent of charge. So that means nuclear force cannot depends on the charge. So they doesn't depends on the charge. That is, the nuclear forces are same for proton neutron. So here generally proton having positive charges, even though nuclear force is how much present between them, the same force will present between the neutron and proton neutron. So nuclear forces are same for proton proton, proton neutron, and a neutron neutron interaction. Last point is nuclear forces have the property of saturation. This means that in the nucleus, any one nucleus interact with only a number of other nucleons nearest to it, and not with all the other nucleons present in the nucleus. This property is known as saturation. Means here it is a nucleus. It is a nucleus. Inside the nucleus, many nucleons present. Right? Many nucleons present inside the nucleus. Here one nucleon, here one nucleon, like this there are the many nucleons are there. Okay, but if you take this nucleus, so this nucleus can interact with this, with this, and with this, right? So how many nucleons present around this nucleus? So this nucleus can interact with these neighboring nucleus only, not with other nucleus which are far away from this. That is called saturation, right? Once again, saturation means if it is a nucleus having many nucleons like this inside. Okay, so if you consider here one nucleus, this nucleus interact with this one, it can interact with this one, it can interact with this one, and it can interact with this one, but this nucleus cannot interact with this one. Why? Because it is very far away from these neighboring nucleons. So this process is called, this property is called saturation property. So once again, let me read. Nuclear forces having the property of saturation. This means that in the nucleus, any one nucleon interact with only number of other nucleons nearest to it, right? How many nucleons are nearer to this one? So for them only this can interact, but it cannot interact the nucleons which present far away from this. And next, and not with all the other nucleons present inside the nucleus. See, it cannot interact with all the nucleons which present inside the nucleus. It only interact with nucleons which are very close to it. That is called property of saturation. Okay friends, so thank you friends, don't forget watching this video.